Hello, this is lesson 4, horizontal and vertical velocity. So in this specific video though, what I really want to talk about is identifying the correct direction of a vector in 2 dimensions. The lab itself will actually take you through a lot of the conceptual things that I want you to know, and so in this specific video it's just going to be to do this. So let's say you've added all these vectors together. You got the magnitude, but now you're trying to find exactly what direction it's pointing. Well, let's start using cardinal directions for a second. So we know that this is north, this is east, this is south, and this is west. And let's say the vector that you get is something along the lines of this. So let me get this nice and something like that. Let's just give it an angle. It's pretty even. Let's say that this is, it looks like 45, but I'm just gonna say it's 60 for the sake of this video. So let's just say it's 60 degrees. So the question would be, how do we describe and correctly label this vector? And let's say that this vector is also a represents 10 meters. So the way that we're gonna do this is there's a naming convention that we can use. So first what you're going to do is you're going to write down the units, the physical quantity itself, which is 10 meters. You're going to write down the angle, 60 degrees. But the problem with this is we can't just leave it as 60 degrees because you could have, for example, maybe something like that way. This could be 60 degrees, right? It could be going this way. This could be 60 degrees, right? And so we need to be specific. 60 degrees where exactly on this axis? We don't want those other two. We just want that specific one that's in our first quadrant. So what we're going to do is we're going to say, we're going to use the north and the east cardinal directions to define it. So what we're going to say is this is actually 60 degrees north of east. And you might be thinking, what the heck does that mean? Well, if we're saying north of east, what we're actually doing is we're saying we're starting east, right? And we're rotating towards the northern direction, right? And how much are we rotating towards the northern direction? 60 degrees. Another way we could actually add this, say this vector and get the exact same answer is 10 meters, right? We also know that we could measure from here, right? Maybe from the north to the east. If this bottom one is 60, that means this one would be 30 degrees. So 10 meters, 30 degrees, we would say east of north, right? Because we're starting north here, and then this vector rotates towards the eastern direction. And how much does it rotate? It rotates 30 degrees. So let's try to do some more in every specific quadrant. So let's get a new one out. We're going to draw 3 different vectors. So we have this. Let me put this out. I'm going to put this. Why don't we put it right here? So we'll have this one that goes this way. We'll say that this is 20 degrees, and this is 10 meters per second. We'll have a blue one that's going maybe exactly that way. Say that this is 20 meters per second squared. And I'm trying to use different vectors, different units that you don't use quite as much, or you're not as used to. We'll have a brown one that goes, oop, I forgot to do an angle. We'll say it is, this angle is 45 degrees. Last but not least, we have maybe a vector like this, where this angle is 75 degrees. And this represents 15 meters. And so the question for these 3 is just, what are, for one, how can we label these vectors correctly so that you have the entire name correctly written or typed? And then what are the different variations of this vector that also give you the exact same direction? So if we go back to our first one, we knew that we could say 10 meters, 60 degrees north of east, and that gave us the exact same thing as 10 meters, 30 degrees east of north. So something you should notice though is right here, complementary angles are key. So let's start with our red vector. First, we'll write down what we got. So with our red vector, we'll call him R. is equal to 10 meters per second, 20 degrees. And then we just look, right? So we know that this is north. We start north. We're rotating towards the west. We can't start north and rotate towards the east, or else we'd have a vector going in that direction. So we're going towards the west. So we're north of north. We're going west of north. 10 meters per second, 20 degrees west of north. Again, because we're starting north and we're rotating towards the western direction. And then our other one that would work would be our complementary angle. So 20 degrees minus, or 90 degrees minus 20 degrees is 70 degrees. And we're just going to switch these, right? So if we were to go from here to here, this would be 70 degrees. And we'd say it's north of west. And if we look at it, this being west, we're starting west and we're going towards the northern direction for this one. Both of these directions are okay. They give the exact same answer. So I might specifically ask, what is the angle north of west specifically? And so you'd have to give me this 70 degrees. So pay attention to that. But technically speaking, on the test, if you gave either one of these, they actually give the exact same direction. And it's the same magnitude. So now we'll go to our blue one, call it B. We look at him. We have 45 degrees. We have 20 meters per second. So let's first write down our magnitude, 20 meters per second squared. And then it's 45 degrees. And here we have a special one. So we can technically say this one is west of south. If we found the complementary angle, well, 45 is exactly half of 90. So you get actually the same thing even if you switch it. So we know that here, from here to here is 45 degrees, and from here to here is 45 degrees. So the third title that you can give this one, and this is only if it's ever at 45 degrees, is 20 meters per second squared southwest. Southwest. So if you had a vector that is exactly halfway between your southern and your western axes, you can just say southwest, right? And you can do that in any quadrant. So you can have a northwestern one. If you had a northwestern one, that would have to be 45 degrees north of west, which would be something that looked like that, right? Exactly halfway in between both of your cardinal directions, north and east. Sorry, I've been saying northwest, and I just drew a northeastern one. So sorry about that. So this is actually northeast. If both of these were 45 degrees. My bad, misspoke. So let's get rid of this. Let's answer the last one, our brown vector. So we'll call this BR. And first we write down our magnitude. 15 meters, 75 degrees. We look at the angle it's going from. It's south of east. Or we take the complementary angle, 15 degrees. We can say that this is east of south. Can't say southeast because it's not a perfect 45 degree angle. But that is how we're going to be doing directions in this class. There are different ways that we can say this too as well. As much as these are cardinal directions, they can also be, for example, axes. So we could say this is, positive x. This could be a positive y. This could be a negative x, and this could be a negative y. So looking at it that way, some of these can change. But they're not going to change in their numbers. They're just going to be changing kind of like how we describe them. So for our red one, instead of saying west of north, you would say 10 meters per second, 20 degrees. If you look at it, it is to the left of the positive y-axis. So I might say to the left of the positive y-axis, or I could say 10 meters per second, 20 degrees, going upwards from the negative x-axis. And this technically works too. Probably used a little bit less, but there'll be times when you want to use your x and your y axes and not use north and south, east or west. So just to continue that really quickly, just so that we're all on the same page, these then would change into 20 meters per second squared. We're going west of south, so we'd be going towards that left direction, rotating that way of our negative y-axis. 20 meters per second squared. Oh, sorry, I forgot to do the angle. So we should have 45 degrees in there. The other one would be 45 degrees below your negative x-axis. And we don't really have a southwestern replacement. So southwest is okay. So southwest, northwest, northeast, or southeast, they could just stay as their own. And for this last one, for our brown vector, we're looking at it. We have that 75, so it's going below the positive x-axis. And this becomes 15 meters, 75 degrees below your positive x-axis, or 15 degrees to the right of your negative y-axis. And so again, directions are just subjective, right? You just need to make sure you can describe them well enough so that your reader can understand exactly what direction you meant. For the worksheet though, you're only gonna really need these guys right here. These are the only ones I'm gonna really care about. But later on, you might find that you wanna say above or below the x-axis or the y-axis or whatever. So that's all I really have for you today. So thank you for watching. If you have questions, please let me know.